And example 2 adds something new that we haven't done yet, which is in part I, determining non-permissible values. Some values of theta may cause you to divide by 0, in which case they're not allowed. So we have to check everywhere where we possibly could divide and make sure we never have it equal to 0. So we're actually going to do the proof first, because in the proof we're going to see a lot of places that we're dividing, because there might sometimes be places that you don't even know. Like, for example, do you know where cotangent causes you to divide by 0? Probably not, unless you change it to cos over sine, and then you're like, oh, it's whenever sine is 0. So we're going to do the proofs first. Draw our line. And in this situation, probably our main strategy is going to be good. I can change cotangent. You could change it to 1 over tan or cos over sine, but since one of our main strategies is getting everything in sine and cos, usually for cotangent, it's going to be a better strategy to change it to cos theta over sine theta. And then cosecant theta is 1 over sine theta. So all of those basic definitions, you really need to know them well for our proofs, because you don't want to be like checking things. Then your proofs take too long. So if you haven't memorized yet that cotangent is cos over sine, or all those reciprocal identities, you'll want to take some time to do that. Early memorization of your different identities that you can use will save you so much time while you're actually doing proofs like this one. Now I have a fraction divided by a fraction, so I go to my fraction rules and multiply by the reciprocal.
Could we just state an early proof like cotangent over cosecant equals cos?
No.
Do we have to actually get to
The only ones you're allowed to use are the ones that we have so far, or anything on your formula sheet. Otherwise, this would say, how did you get from here to here? Right? Because otherwise you could just go, okay, I'll show you. Let's finish this up first. Now we can cancel those out. And so we get cos of theta. So left side equals right side, Q, E, D. Very nice. And we're done. Okay? So now that we've proven this, you're wondering, can you use it in another proof later on? Not because, no. Yes and no. You'd still have to show all your work. Okay? Anytime that you're doing more than one step, so if you went from here to here, that involves more than one step. Okay? Okay, and I have, this was on a final exam. Okay? If it was this proof. Whoops. There we go. Ladies and gentlemen. Wow, I'm getting ahead of myself. Can't spell. Ladies and gentlemen, it is obvious. It was a much more complicated proof than this one, but this is what the student wrote, that cotangent theta over cosecant theta equals cos theta. Therefore, left side equals right side, QE. Yeah.
Did they get the mark?
No, thank God. They got the smiley face without the smiley face. Yeah. No, all the proofs work. You know they're supposed to be true in the end. If they say prove, you can do it, but you can't just say, yeah, I agree. Good job. Way to go, examiner. You really came up with a good one. I like to get full marks, thank you. It's like multiple choice. A, B, C, D. Yep, the answer's there. I know it. Yeah. So that isn't quite enough for a proof. anytime you skip one, I go, oh, obvious, right? As soon as you look at it, it's like that screams cos like crazy. So you have to show your work. All right. As far as strategies, your main strategy is going to be a good one here. Your main strategy is going to be a really good one because there's only one thing that needs to be changed to sine and cos. That would be secant. It's 1 over cos. And the really nice thing about this question is that now everything's in cos. So it kind of fits with two strategies we've learned. Change everything to the same function. Okay? And now I have a fraction with fractions inside. I'd like to get a single fraction on the top, single fraction on the bottom. This one's interesting because sometimes students miss out that this is already a single fraction in your numerator. It's over 1. Big line, but the bottom I'm going to need a common denominator. So I need to multiply 1 by cos theta over cos theta, and then on the bottom I'm going to have cos theta plus 1 over cos theta. Oh, nice. The work's done for me. That was fancy. Now you can multiply by the reciprocal. It just happened, just naturally. It just knew what I was going to do next. That was so nice of the smartboard. They don't call it a smartboard for nothing. So we multiply by the reciprocal, can put brackets around the ones that have a plus sign because that gets grouped together, but those brackets are identical. So you can simplify, and you just get cos theta. Therefore, the left side equals the right side. Okay, so now we've proven both of these. Oh, what did I do on the last one? I erased my proof because of my ladies and gentlemen story. Jeepers. I'll quickly rewrite it. Uh-oh. It's all frozen. I hate it when it freezes. Okay, let's pull out our highlighter, maybe. There we go. Pull out our highlighter. Can you see where we're dividing? Highlight places where we've divided. Yes? And I guess technically here, but cosecant changes to 1 over sine. So what do we have for non-permissible values? For NPVs, non-permissible values. Oh, we didn't do the QED. Here we go. Fancy. So for our non-permissible values, I like this pen. What do we know? We know that sine theta can't equal 0. When is sine theta equal 0? Theta can't equal k pi, where k is an integer. No, you still have to find the non-permissible values for theta. So if you read the question, it says, determine the non-permissible values for theta. If it had said, determine the non-permissible values for sine theta, you would have been done. But it wanted you to find them for theta. Boy, using this pen just makes me feel like I'm smarter. or more. And let's look at the second one, non-permissible values. Let's go. Oh, but it freezes. So it slows me down. Okay. Non-permissible values. Where are we dividing? Take out our highlighter. We're dividing here, cos theta. Maybe that highlights in a bit. No, it's the computer that's slow. We're dividing here by cos theta plus 1. You notice that? Here's another cos theta. Okay, so for our non-permissible values, when we look at all the places where we're dividing, okay, we can say that, do I dare? We can say that cos of theta can't equal 0, and cos of theta can't equal negative 1? Negative 1. So theta can't equal, where's cos at 0? Pi over 2, 3 pi over 2, 5 pi over 2. Are you okay if I write pi over 2 plus k pi? Where k is an integer.
You have to write out cos theta doesn't equal twice. You just use doesn't equal 0, comma, negative 1.
Cos theta doesn't equal 0. Oh, you could do that. You could write both of them together, yeah. I haven't finished solving yet. I need to also have theta can't equal. When is cos of theta equal to negative 1? Pi. That's the only time, right? So I could write pi plus 2k pi, where k is an integer. So the non-permissible values are often easier once you've finished your proof, because you have to look at all the different places where you're dividing. This one, that cos theta plus 1, is sometimes easy to miss. Okay, questions for practice on this one? 4, 8, aye, aye, 9, aye, aye, and big I, big I.